Well, because the last digit's a 0, do you need it? Yes, you do. Because if you are approximating, you have to show all of the digits out to 3 digits to the right of the decimal point, even if it's a 0. Okay? And total area inside of. So now what I could do is I could find, because I solved for my theta values down here, that theta is pi over 8 plus pi halves n. So I could keep adding 4 pi over 8 to get this theta value. Oops, let me keep it the same color. Theta sub 3 would be equal to, if I added 4 pi over 8, what is that? And if I added 4 pi over 8, so what I could do is to verify that the areas or those regions are all have the same area, is I could say 0.5. Now I need you to look up here and follow what I got going on. 0.5 times the integral from pi over 8 to 5 pi over 8 of r1 squared d theta plus 0.5 times the integral from 5 pi over 8 to 9 pi over 8 of r2 squared d theta plus 0.5 times the integral from 9 pi over 8 to 13 pi over 8 of r1 squared d theta plus 0.5 times the integral from 13 pi over 8 to 17 pi over 8 of r2 squared d theta. Adding up all 4 of those integrals ought to give me the same exact value, 8.480, as I got here, assume if all of these are exactly the same. So I'm gonna plug that in. Do you see why I put 17 pi over 8 instead of pi over 8? Why? Because pi over 8 and 17 pi over 8 are what? Coterminal. They lie on that same line, right? It's just one rotation more. 17 pi over 8 is one rotation more. So let's go do that. So what I'm going to say is this plus 0.5 times math 9 5 pi over 8 to 9 pi over 8 of bars, y bars, polar, r2 squared d theta plus 0.5 times math 9 of, I started at, where am I, 9 pi over 8? Over 8 to 13 pi over 8 of bars, y bars, polar, r1 squared d theta. Oops. Plus 0.5 times math 9 13 pi over 8 to 17 pi over 8 of bars, y bars, polar are 2 squared d theta. Enter. What a coincidence. I got 8.480. And you can see it was exactly because I left up there on my calculator screen what I had as the initial region multiplied by 4. So it's all the way out, not just to 3 digits, like, oh, it's kind of accurate, but it's all the way out. In fact, it's going to be exactly the same based on symmetry. Yes, ma'am.
Would it ever give you a problem where it's not symmetrical?
It would be obvious that it wasn't symmetric. It wouldn't ever look like it is, but it's not, you know? But, does that?
So then you just have to find the limits of integration multiple times.
Mm-hmm. Yeah, all those different theta values. 18. Does this make sense? Oh, and by the way, for sure, this is going to be on the calculator portion. Now, is it possible that it's on non-calculator portion? Well, anything is possible, but if this were on the non-calculator portion, then they would make it easier. Like, they would give you the theta values. Even on a calculator portion, oftentimes they give you the theta values. But they would give you the theta values, or they would only have you set up the integral and not evaluate it. You know what I mean? Like, it would be an easier type of problem. But if they're having you go ahead and work this out, or give you something like this with no graph associated with it, you have your calculator. So let's go ahead and check this out. I'm going to plug in, I'm going to call this the first one just r sub 1, and the second one r sub 2. They tell you that this is a circle and a line, so that should be not too bad. 2 sine. Two sine of theta plus pi over 4. Then the next one is secant. Uh-oh, I don't have a secant button. I can't do this, guys. Just kidding. If you go to alpha f1 and then go to the numerator over denominator 1, so you have 1 divided by, right? That's going to be cosine of theta minus pi over 4. So for my window, because they don't tell me, I'm going to go from 0. I like going from 0 to pi first. And I'm going to go from negative 2 to negative 2 to 2. Why am I choosing negative 2 to 2, guys? So why do you think it took so long? Because my theta step was still at 0.1. So if you wanted to be, it's all about the resolution of it, right? Even though we have, the screen is made up of these individual, pixels, but you're going to get a better, really as it's going through, how far do you move your theta to then check the x and y values to plug in the points. Does that make sense? So if you choose often, like to plug in more, so your theta step is smaller, then it's gonna be slower but more detailed or more accurate. Whereas otherwise it might be here, there, and it'll do like a line segment, line segment, line segment, and you're like, no, it actually should be curved. Anyway, so we're looking for the area that is inside the circle and above the line. So right there is what we're looking at, right? So it kind of looks to me like that's going to be 0 to pi halves. Let's check it out. Do you see why I think that's pi halves? So we have the line, which is the r sub 2, which I can make bold again. It sure looks like that's going to stop at pi halves. Yay! Right? Oh. So what I would say is, for this, what you want to do is you want to, I'm going to take a picture of this and then so what I'm going to do, this is my r sub 1, which is right there. And this right here is my r sub 2. And I already found out that the theta values are going to be theta 1 equals 0. And theta 2 equals pi halves. So, whoops, what'd I do? There you go. So, what I would do is, I'm looking for the region that is inside, right? Inside the circle and above that line. So, I would want to sweep through all the way out to my blue, minus sweeping out to the line, which is just a rectangle. Do you see that? Because this is the region, let me get my highlighter out. This is the region that I'm looking for, is inside that circle but above that line, right? So what I would say is for the area, I'd say 1/2 times the integral from 0 to pi halves of something squared d theta, and that something squared is my r sub 1, which was my 2 sine of theta plus pi over 4. Or my r sub 1. And that thing is squared d theta. And then I would subtract off, let's just do 1/2 integral from 0 to pi over 2 of r2 squared d theta. So really I could have called that r1 squared, right? So I would have to define somewhere r1 equals 2 sine of theta plus pi over 4. And I would say r2 equals, what was it again? Secant of